Okay, so I'm working right now with example 3 where we have repeating linear factors. Okay, so let's see if we understand what I mean when we say repeating linear factors. So we are now integrating a, an expression or a function where we have the degree of the top of the numerator is less than the degree of the denominator. So I cannot do long division. So what I'm going to have to do is I'm going to have to represent this using partial fractions. So the first step, as you all know, is to factor the denominator, factor the x, and I get x squared plus 2x plus 1. And then you can see that this is x plus 1 times x plus 1, right? It repeats. So it's x times x plus 1 squared. Okay? So now if I'm going to represent the integrand rather, using partial fractions, I'm going to consider the fact that this repeats. Okay? So instead of having two fractions, I'm going to have 3 fractions. So what are the 3 fractions? The 3 fractions. One is a divided by x, right? The other one is b divided by x plus 1. And the other one is c divided by x plus 1 squared. Okay? Now, this is because the linear factor repeats. So it makes sense, right? Imagine that you have 3 divided by x plus 1, and you added to 2 divided by x plus 1 squared. So what would be the LCD of these two expressions, of expression 1 and expression 1 and expression 2? The LCD would be x plus 1 squared. Correct? So you know that's one of the reasons why you have to understand, you have to repeat these represented with 2 fractions. Okay, so I'm going to go to the next page because I'm going to need a lot of space. I'm afraid that I don't have it here. So here it goes, 5x squared plus 20x plus 6 divided by x to the third plus 2x squared plus x equals a divided by x plus b divided by x plus 1 plus c divided by x plus 1 squared. Okay? And what I'm going to do is I'm going to multiply both sides of the equal sign by the LCD. So the LCD, and now you gotta be careful here because the LCD is x plus 1 squared. So here is x plus 1 squared, and this one is x plus 1 squared. My bad. I'm sorry, it doesn't get written. It's too far at the top. And x plus 1 squared. Okay? Make sure that you understand it's x plus 1 squared. You don't have to repeat x plus 1 squared more than once. Okay, so here it goes. This gets cancelled. Yes. And this x cancels this x. This x plus 1 cancels one of the x plus 1's, right? And this x plus 1 squared cancels this x plus 1 squared. So let's just write down what we have. I have, let me write it in different colors. So 5x squared plus 20x plus 6. That's what I have on the left. Is a times x plus 1 squared, right? Plus, remember that this one cancels with one of those. So I have b times x plus 1. It wasn't very clear in the way I canceled there. So let me just make sure that you see it is to cancel, okay? And then here I have c times x. Okay? So now I have to find a way to find a, b, and c. So so obviously, if I take the value of, let's say, x equals 0, I will cancel my c's, right? So that probably would be the first one that I think about. Take x equals 0, so this is 0, this is 0, then I have 6 is equal, right? Remember, I'm taking values of x because I want to find a, b, and c. So a times 0 plus 1 squared is a, right? And here this gets cancelled, 0, and then c gets cancelled. So that means that a is 6. Okay, I already found a. Okay, so now I'm going to take x equals to -1 because I know that it will cancel these factors right here. So I have 5 times -1 squared is 1, minus 20, because remember that x is -1, plus 6 is equals to, so a times -1, and it gets cancelled, and b gets cancelled, right? And then c is times -1. Okay, so what do I have here? I have 5 minus 20 is -15, plus 6 is -9, is equals to -c. That means that c is 9. Okay, so now how do I find the value of b, because I still need b? Well, take another value. Let's make x equals 1. Okay, so what happens if I have x equals 1? So I have 5 plus 20 plus 6, right? That happens to be 31. 31. I'm substituting right here on the left. Is equal to 8 times 1 plus 1 is 2, and 2 squared is 4, plus b times 1 is b times 1 plus 1 is 2, so it's 2b, plus 1 times c is c. Okay, remember x is equals to 1, so the equation is 31 is equals to 4a plus 2b plus c. But I know that a is 6, so I have 24 plus 2b, and c is 9. So 31 is 24 plus 9 is 33 plus 2b. So that means that 2b is -2. It means that b is -1. Yes, I have A, B, and C. Okay, so I'm going to go to the next page. Remember that you can always come back and check it out. So what I have now is that my integral 5x squared plus 20x plus 6 divided by x cubed plus 2x squared plus x dx can be represented as the integral of, I'm going to write it in here so you understand where I got these different expressions. Okay, b divided by x plus 1 plus c divided by x plus 1 squared, right? And all that is dx. But remember that I have a is 6, b was -1. Hope I'm putting these values right. And c is equals to 9. Okay, you can check your work on the back. Okay, so the integral becomes the integral of a6, right? So it's 6 divided by x plus -1. So I may as well delete or erase that plus, so it's going to be minus, right? 1 divided by x plus 1, and c is 9 divided by x plus 1 squared. Dx. Okay? So obviously this is a really easy integral to find. 6 divided by x, dx is really basically 6 ln of x. correct? I'm not going to put the plus c because I'm going to add it at the end. So hopefully you understand what you're doing is bringing the 6 out, and that will be dx divided by x. That's ln of x. The integral of 1 divided by x plus 1 dx, right? All you need to do is make u equals x plus 1. Du is dx, and your integral becomes du divided by u, which is ln of u. And of course, since ln of u, and we're going to write it right here, ln of u, it will be ln of x plus 1. Okay? We're good? Alright, so now the last one could be the integral of 9 divided by x plus 1 squared dx. Well, this is also very easy because I can do my u sub without any problem. Du is dx. And what I have here is the integral of 9 divided by u squared du. And that's 9 integral of u to the negative 2 du, which is 9 times u to the negative 1 divided by negative 1, which is the same thing as negative 9 divided by u, or negative 9 divided by x plus 1. Okay? Alright, so what I'm going to do is I'm going to bring this, that, and this other thing right here into my answer, okay? So it's going to be, my final answer is going to be 6 times ln of the absolute value of x, okay? Minus, because we have a minus here, minus ln of x plus 1. Let me make sure that I write this correctly so you don't get confused, okay? This is ln of absolute value of x. That ln didn't get written very clearly. And minus, and now I'm going to write this in right here, 9 divided by x plus 1 plus a constant. Okay? Now, I can combine these two logs. Yeah, I'm going to make a line here. That would be ln of x to the 6, right? And because I have a minus, I can put it in the denominator, x plus 1. And this is not a log, okay? This is not a log, so I had to put it just as it is. I cannot do anything with it. I cannot touch it, okay? So this is the final answer for example 3, where we have the denominator represented as the product of linear factors that repeat.